Students, once again welcome to another video from iCampSA. In today's video we're going to be doing a past paper question, and this particular paper was written in 2017. It was a common paper, so it was written by all the provinces in South Africa. The area of focus is trigonometry and trigonometric functions. Let's get into it. So for question 4, given 4 cot theta plus 3 is equal to 0, and 0 is equal to and theta is found between 0 and 180 degrees. Use a sketch to determine the following. Okay, now let's come here before we can even get to the sketching parts. Let's try to make sense of what we are given there. For 4.1 we are given 4 cot theta plus 3 is equal to 0, and then that theta is between 0 degrees and 180 degrees. First thing first, let's try to rearrange 4 cot theta to something that we are used to and something that we can actually work with. First thing first, we have to take that plus 3 to the other side, so we're going to have 4 cot theta is equal to negative 3. We divide by 4 on both sides, and therefore cot theta is equal to negative 3 over 4. But we know that cot theta is a reciprocal of what? Of tan. Therefore we can change this to what? To 1 over tan theta. 1 over tan theta is equal to negative 3 over 4. Let's make tan theta the subject. Therefore tan theta is equal to negative 4 over 3. You use cross multiplication to do that. Okay, so now once we are here, we can see that we have two conditions essentially here, and the first condition is that tan theta, the ratio of tan theta is what? Is negative. Okay, and then the second condition is that theta is found between 0 degrees and 180 degrees. 0 degrees and 180 degrees. Those are the two conditions. Then we can come to the sketching part to see where our terminal arm will be located. Okay, so there we have your cardinal points. Let's put the degrees. We have 0 degrees here, that's 90 degrees, 180 degrees, 270 degrees, all the way up to 360 degrees. Okay, let's start with this condition that theta will be found in what? Between 0 and 180 degrees. So which two quadrants do we found between those two maximum and minimum, 0 and 180 degrees? We found quadrant 1, and quadrant 2. And let's remind ourselves of the CAST method. The CAST method is CAST. Okay, so it tells us that in the first quadrant, where you see A, all the trigonometric ratios are positive, and in the second quadrant only sine, in the third only tan, and in the fourth quadrant only cosine is positive. And then what do we have next here? Let's come here now to what we have here. We have tan theta being equal to negative 4 over 3. Okay, so we have to look for the areas where tan theta is actually negative. So first thing first, in first quadrant all trigonometric ratios are positive, so also tan theta is positive. And in third quadrant, where you see tan theta is positive, therefore we are left with second quadrant where only sine is positive, and the fourth quadrant where only cosine is positive. And then where we have two stars, that is where our terminal arm will be located. Here, that is where our terminal arm will be located for this particular theta. Okay, and this is our theta here. Okay, and then next, let's just complete this triangle and make it a right angle triangle like that. Tan theta is what? Tan theta is opposite over adjacent. So we're gonna have the value of y here is gonna be 4 because the terminal arm is above the x-axis, so it's in the positive side of y, and then x, the adjacent side, is gonna be what? Is gonna be -3. And now we have another unknown, of which is the length of the terminal arm. The length of the terminal arm, we can say it's from the origin there. Let's call it what? Let's call it o OP. Yeah, that line, we'll call it OP. OP would give us the length of the terminal arm. And when you look at that right triangle that we have just constructed there, it is we have two sides. We have the adjacent and the opposite side, and then we have the unknown side. OP is what? Is the hypotenuse side, and we can use the Pythagoras OP squared. We can use the Pythagoras theorem in order to determine the length of OP. Say r squared. We know that is OP squared is equal to, what is the value of x? Value of x is -3 squared plus what's the value of y is 4 squared. Okay, therefore OP squared is equal to, what is -3 squared? That is going to be 9, a +9, plus what is 4 squared is a +16. So 9 plus 16 is going to be what? It's going to be 25, and then we have OP squared on this side. And then the next step, because we want to solve for OP, we have to introduce a square root on both sides, and therefore OP is equal to 5 units. That will be our OP here, 5 units. Okay, now we have simplified and we have came to understand where our terminal arm will be located, and we have all the sides of the right angle triangle that you see there. And then we can come here, use a sketch to determine the value of the following. Do not use a calculator. Of cos theta. So that will be 4.1.1a. So we have already drawn the sketch here. Let's actually do 4.1.1a here. We are looking for what? We are looking for cos theta. What is cos theta? Cos theta is adjacent side of our hypotenuse, and adjacent side is our x over the hypotenuse, which is r. What is the value of x? Is -3 over 5. That is the value of cos theta. Okay, and then next we have 4.1.1b. 4.1.1b. Let's come here for 4.1.1b. We have to determine the value of what now? Of 3 sine theta multiplied by sec theta over tan theta. We have to determine the value of 3 sine theta multiplied by sec theta over tan theta. Okay, so we come here, say it's equal to what is the ratio of sine theta? Sine theta is opposite over adjacent, so sorry, it's opposite over the hypotenuse. So sine theta is y over r, and then we have sec theta. Sec theta is the reciprocal of what? Of cos theta. Therefore sec theta is 1 over cos theta divided by tan theta. What is tan theta? Tan theta is adjacent, which is x over the hypotenuse, which is r. And then once we are here, we can substitute the values that we know, but we have already determined what is tan theta. We have determined that tan theta is -4 over 3, but we can also come here. This is the opposite side, which is 4, and this is the adjacent side, which is -3. So we know that tan theta on the bottom part is gonna be -4 over 3, -4 over 3. That is our tan theta. And then next, sin theta. What is sin theta? It's gonna be 3 into y. What's the value of y? It's 4 over r. R is 5, so we're gonna have 4 over 5 multiplied by 1 over cos theta. So the other way that we can use, we can simply just evaluate sec theta directly from the values we are given, because if sec theta is the reciprocal of cos theta, we know then that since cos theta is what? Cos theta is adjacent over hypotenuse. That means sec theta is now hypotenuse over the adjacent side. So we can say here sec theta is what? Is hypotenuse over the adjacent side. That is our sec theta, and this is equal to 3 multiplied by 4 over 5. That will be 12 over 5. That will be 12 over 5 into, what is the hypotenuse? It's 5. The adjacent is -3. Double check. Yes, it is. Okay, all of this divided by -4 over 3. Let's deal with the numerator. 12 over 5 multiplied by 5 over -3. We're going to have a negative answer of the 5. We'll cancel the 5 here, and then we'll be left with 12 divided by -3. That would be -4 over -4 divided by 3. This will be equal to -4 multiplied by 3 over -4. Yes, when we change the division sign to a multiplication, it becomes that the -4 and the -4 will cancel. Therefore, we'll be left with 3, and that is our answer here. Okay, and that was 4.1.1b. Okay, and then next, for 4.1.2, we are asked that hence show that sine squared theta minus 1 is equal to negative cos squared theta. So here we are essentially proving an identity here. We have to show that sine squared theta minus 1 is equal to negative cos squared theta. Okay, is equal to negative cos squared theta. Okay, so here, since we are given this theta in this triangle to work with, we can just take the values that we have here, and then we show that one side is equal to something and the other side is equal to something. What do I mean by that? Let's go to 4.1.2. in fact, copy where it's pasted here, and then drop. And hence show that sine squared theta 4.1.2 for 4.1.2 sine squared theta minus 1 is equal to negative cos squared theta. Let's take the left hand side first. Is equal to negative sine squared theta minus 1. What is sine theta? Sine theta, the ratio of sine theta is opposite over adjacent, is y over r squared minus 1. What is y over r? What's the value of y? It's 4 over 5 squared. It's 4 over 5 squared minus 1. This will be equal to, let me add a page instead of, okay, so this will be equal to 4 over 5 squared. It will be 16 over 25. 16 over 25 minus 1 is equal to 25, common denominator, 16 minus 25 will be, what is 16 minus 25? That is negative 9 over 25. Negative 9 over 25. That's the solution that we have here. Now let's go ahead and do the right hand side. For the right hand side, what do we have? We have negative cos squared theta. This is equal to minus negative cos squared theta is going to be minus open bracket. What is cos theta? Cos theta will be x adjacent over hypotenuse, all of the squared, so we're going to have a negative open brackets. The value of x is negative 3 and the hypotenuse 5 is 5, so we can have negative 3 over 5 squared. Now let's square what we have there. We have negative 3 squared is going to be what? It's going to be 9. Negative 5 squared is going to be 25. Therefore the answer is negative 9 over 25. And then we say therefore right hand side is equal to left hand side Okay, and then next for 4.2, copy. Let's come here. For 4.2 we have to now simplify the following expression without using calculator. 4.2, let's see. So what are we having here? These are special angles. You already know what the special angles are, I hope, because 30 degrees multiplied by tan 60 degrees plus cosec squared 45 degrees multiplied by sine squared 60 degrees. Okay, what is cos 30? Special angle of cos 30, that should be cos is adjacent over hypotenuse. That should be root 3 over 2. Yeah, we're gonna have root 3 over 2 close brackets multiplied by what is tan 60? Tan 60 is opposite over adjacent. Once again, that is gonna be root 3. It's just gonna be root 3 plus cosec squared 45. Cosec is the reciprocal of sine 45, and cosec is, instead of being opposite over hypotenuse, is hypotenuse over the opposite side. So for for sine cosec 45, we're gonna have hypotenuse. The hypotenuse will be root 2 over 1 squared multiplied by sine squared 60. What will be sine squared 60? What is sine of 60? Sine 60 is opposite over hypotenuse, so it's gonna be root 3 over 2 squared. Okay, and then once we are here, this is gonna be equal to root 3 multiplied by root 3 is gonna be 3 over 2 plus root 2 squared is gonna be 2 multiplied by root 3 over 2 squared. This is gonna be 3 over 4, and then we're gonna have 3 over 2 plus 2 multiplied by 4 divided by 4. Sorry, 2 multiplied by 3 divided by 4. That will be 6 over 4. 6 over 4 is the same as 3 over 2. So we have 3 over 2 plus 3 over 2. This is actually equal to same base, so we just add the numerators. 3 plus 3, which would be 6. 6 divided by 2, and this would be equal to 3. So if you are a little bit confused about this, Here are the triangles that we use when dealing with special angles. Where the special triangles, if you have been given the copy, if you have already been introduced to the fan method, you are also welcome to use it when working with the special angles, with the special angles. But normally we just use these two triangles here, just put them right here, just in case we were confused. Okay, so that was our 4.2. And then for 4.3, solve for theta correct to 2 decimal places if that sine theta is equal to that. Once they tell you that correct to 2 decimal places, just know that you'll have to use your calculator. Okay, so for 4.3, let's see what are we given. Let's come here, drop to 4.3. Okay, so here we have 4/3 sine theta is equal to cos 37 degrees, and theta is found between what? It's found between 0 and 90 degrees. So theta is an acute angle, so we expect theta to be positive, because all the trigonometric ratios are positive in the first quadrant. So first thing first, we start by isolating sine theta. Let's take 4/3 to the other side by dividing by 4/3 on both sides, and then we will have 1 divided by 4/3, we will have 3/4 cos 37 degrees. Okay, so sine theta, just punch wherever we have the 3/4 cos 37, whatever you have on the right hand side on your calculator, get the answer of 0. Let's see, correct to 2 decimal places, you get the answer of 0.55998. you get that answer, and then that means theta will be equal to sine inverse. You insert the answer, and then we solve for theta 898. Okay, therefore theta is equal to 36.80. Theta is equal to 36.80 degrees. That is your theta. Pretty straightforward, I hope. Okay, so that marks the end of question 4. Let's go ahead and do question 5. So for question 5, you are given f at x is equal to sine x minus 1 and g at x is equal to 2 cos x. So for question 5.1, we are given f at x is equal to sine x minus 1 and g at x is equal to 2 cos x for the interval of 0 to 270 degrees. So the domain has been limited between 0 and 270 degrees. Okay, so first thing first, before we even go any further, let's come here to what are we given. Sine x, sine x minus 1. What is that minus 1 represent? It represents that the function has been shifted by 1 unit downwards, is equal to g at x 2 cos x, and that 2 cos x, it means that the function of cosine has been stretched by a factor of 2. Okay, that's a vertical stretch, and it also represents our amplitude. Okay, And then what else? Once we are here, basically let's just go into our table, and then we start sketching. We start sketching the function. Okay, so we actually have two functions, so let's see. I have one here, and then we'll use the intervals of what, of 90. So it's 0, 90. Oh, it's gonna be very 0, 90, 180, 270. It becomes very short when you use the interval of 90. But anyway, let's just keep them. So these are the intervals we're gonna use. Okay, and then we have to sketch two functions as well as just make two tables. Okay, first one, x is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. The first one is the function of sine. So y is equal to sine x minus 1, and then the other one is the function of g. So x, we use 0, 90 degrees, 180, 270 degrees, 360 degrees, and then your y will be 2 cos x. Okay, so here what do we do? Let's find the corresponding y values. Sine of 0 minus 1 will be -1, would be -1. Sine of 90 minus 1 will be 0. Sine of 180 minus 1 will be -1. Sine of 270, why did I end up going to 360? Because we ended 270. 270 is -2. Yeah, so we don't have 360 because the domain ends at 270. So let's delete this. Remember the restriction we were given here, that the domain is x only exists for the values between 0 and 270 degrees for these functions we are working with. Let's just go ahead and do the second one. So we have 2 cos 0, that will be 2, and 2 cos of 90, which is 0, 180, which is -2, 270, which is 0, Okay, and then let's sketch our function. Okay, let me shift this one a bit lower. Okay, so we're gonna have let's say 1, 2, 1, 1, 2, and then we have 90, 180, 270. 90, 180, 270. So it's 1, 2, -1, -2, 90 degrees, 180, and 270 degrees. Okay, let's start by sketching the sine function, where x is 0, y is -1, where x is 90. y is 0 where x is 180, y is -1 where x is 270, y is -2, -270. Okay, and then and then we join our points, and that is our function there. It would look something like that. And then let's draw the cosine function where x is 0, y is 2. Start from there where x is 90, where x is 90, y is 0, where x is 180, 180. What is this? Y is -2 here, and then where x is 270, y is 0. Okay, then let's sketch our function. Like that, and then the other. Yeah, so it looks like that. So our functions will look like that. This is the g function, and then this is the f function. Okay, yeah, that is that. Nothing more, nothing less. Okay, except for labeling our axis. I'm gonna say this is the x and this is the y-axis. Okay, 5.2, write down the amplitude of g. Amplitude of g, we said, is given by that coefficient of cos x. There is gonna be 2, and the amplitude is always positive. Please don't make that mistake of writing a negative amplitude. So for 5.2.1, the amplitude is equal to 2. Okay, and then the range of f, the function of f is what? Is that sine function. Let's see what's the minimum point for this function. The minimum point is here, -2, and the maximum point is there at 0. So the range, this is 5.2.2. so therefore the range of f will be, y is the element, we said it goes from -2 to 0. That will be the range of f. Okay, and then next, use the graph to determine the number of solutions to f at x in the interval of 0 to of this interval that we are working with, 0 to 270 degrees. So we have to determine actually how many times will be the the graph with these graphs actually be equal, and that is where the graphs intersect. And then let's come here, you see the graphs intersect here, so they have the same outcome there at night, and as you can even see from the table that they are both equal to 0, so their graphs are equal. And then once again, where here we don't know this point there, we don't know because we use the intervals of 90, but maybe if we use the interval of 45, it was gonna be maybe 215 or 225 or something. But yeah, you can see that the graphs are intersect at 2 points, so it will have two solutions to f at x is equal to g at x. For 5.3.1, you don't have to write that the solution will be x is equal to 90 degrees. No, it will have two number of solutions, like how many times they intersect. So 5.3.1, it has two solutions, and then next values of 5.3.2, values of x in the interval of 0 to 180. So only consider between 0 to 180, for which sine 2x is equal to 2 cos x, for which sine 2x is equal to cos 2x. Okay, so this one you have to actually be able to see. Remember that cos x is that 2 cos x is that g function, and here we have 2 cos x, and then we have sine x minus 1. That is the f function that we have actually constructed here. Okay, if we were to take that 2 to the other side, we're gonna have sine x minus 2, sine x minus 2 is equal to 2 cos x. You see that sine x minus 2 is similar to this function of f of sine x minus 1. It's just that this one has been shifted 2 units downward, so it will look something like this. Roughly, it will look something like this. Okay. And we are only considering the interval of 0 to 180. That will be the function of sine x minus 2. If you want, we can roughly sketch it. Let's say sine of 0 minus 2, it gives us what? It gives us minus 2. And then let's say sine 0, sine 90 minus 2, it gives us negative 1. And then let's say sine 180 minus 2, it gives us minus 2 again, and then it ends there. Okay, and then values of, also we have to determine the values of x in the interval, for which sine 2x, since after we rearrange this to sine x minus 2 is equal to 2 cos x will be equal. So we can now come to the graph. So you can see here that they will be equal there at 90 and where at 180. Those are the 2 points where they will be equal. So already that's the solution, because we have to use the graph. So it's at 90 where x is equal to 90 and where x is equal to 180 degrees. You just have to rearrange it so that you can see what you are actually dealing with. Okay, so that is 5.3.2. First thing first, we rearrange the functions. We were given sine x is equal to 2 plus 2 cos x, right? 2 plus 2 cos x, and then we said this is essentially sine x minus 2 is equal to 2 cos x. And then from the graphs, after sketching that function, we realize that these two functions are equal, where x is equal to what? 90 degrees, and where x is equal to 180 degrees. Those are the 2 points. Okay. Okay, so that was the last question for question 5. Last question. Let's go ahead and do question 6. Let's see. Okay, for question 6, RQ is a vertical pole. The foot of the pole Q is on the same horizontal plane as P. Okay, and as the pole is anchored with the wire cables RS and RP, the angle of depression from the top of the pole is point P. Top of the pole to point P is 47 degrees. PR is 21 meters and QS is 17 meters. Okay, what else do we are we given? RPQ is equal to theta. RPQ is equal to theta. Okay, and then we're asked to write down the size of angle theta, and it's 1 mark, so you can just read it from the sketch there. Theta is equal to 47 degrees, and you give the reason theta is equal to 47 degrees. Since this is the angle of elevation of r from P, so we say angle of elevation equal to angle of depression. We're given the angle of depression, which is 47 degrees there, so those two are equal since they are alternating angles. Okay, and then for 6.2, hence calculate the length RQ. So now we have 47 degrees here, and we are asked to calculate the length RQ, and we were given that length 21 of PR, and you must recognize that this is actually a right angle triangle. So we have 21 the hypotenuse side, we have 47, we are looking for RQ, the opposite side. We can use the sine function to determine RQ. So sine theta is equal to opposite RQ over hypotenuse PR. Okay, let's make RQ the subject. RQ is what we're looking for, is equal to PR cross multiplication. What's the value of PR? Is 21 meters multiplied by sine theta. What is the value of theta? Is 47 degrees. Therefore RQ is equal to 21 sine 47 is equal to 15.36 meters. 15.36 meters. Okay, so that's the value of 15.36 meters. That's the value of RQ. Okay, and then hence calculate the size of angle S, this angle here. Now recognize that this is also a right angle triangle, because also this angle here is 90 degrees. Angles on a straight line, remember your geometry. Okay, so we have two sides there on that right angle triangle. We have RQ, the side that is facing the angle S that we are looking for, and we have 17, the side that is adjacent. So we have an opposite side and the adjacent side, which our trigonometric ratio we can use to determine angle S. It's the tan trigonometric ratio. So for 6.3, we're gonna say 6.3 is gonna be tan S is equal to opposite. What's the opposite side? The one 15.36 is 15.36 meters over the adjacent side, which is 17 meters. Therefore angle S is equal to tan inverse of 15.36 divided by 17, and therefore angle S is equal to shift tan inverse, punch this in your calculator, 15.36 over 17, and there you get 42.10. So it's 42.10 degrees. 42.10 degrees. Okay, and then for 6.4, if PQ and S lie in a straight line, okay, how far apart are the anchors of the wire cable? What are the anchors? The anchors is what is P and is P and S. These are the anchors of the wire cable. Remember, the pole with wires are S. The wire is, these are your wires, that, and these are your wires of that pole are Q. So those are your wires there. Okay, it's on the same, okay, anchored with the wires. Yeah, so the anchors would be at P and S. So we are essentially asked to calculate how far we calculate the distance. We're asked to calculate the distance of what? Of PS. You know, when they say how far apart are the anchors, how far apart are the anchors of the wire cables, how far we have to calculate the distance of PS. So to do that, what do we have to do? We have to calculate side PQ, because we already know that QS is what is 17. Then we have to calculate PQ. Did we calculate? Oh, we haven't calculated PQ. We have to calculate PQ, and then add the two. That will give us the length of PS. Okay, so let's consider the first or the highlighted right angle triangle. PQ is adjacent to 47 degrees, and we have a hypotenuse side there of 21 meters. So we can use the cosine function to determine the value of PQ. This is 6.4. So we're gonna say cos 47 degrees is equal to adjacent side, which is what? PQ. What we are looking for is equal to PQ divided by the hypotenuse side, which is 21 meters, or PR, 21 meters. Therefore PQ is equal to 21 multiplied by cos 47 degrees, of which would give us PQ, which is equal to 21 cos 47, which is 14.32 meters, 14.32 meters. So we have PQ, but we're looking to determine how far the anchors apart. So we have to calculate PS, and then PS is equal to PQ plus QS, which is 17 meters. So PQ is 14.32 plus 17. Therefore PS is gonna be 31.32 meters. 31.32 meters. So the anchors are, let's just put that in statement, the anchors are 31.32 meters apart. 31.32 meters apart. Okay, and that is how you go about solving that question 6.4. And I think, yeah, this is the last part of this lesson. Yeah, I hope you guys learned something from today's lesson, and until we meet again, I wish you all good luck and good studying.